Subscribe our Nehra Classes YouTube channel to watch free live training sessions and to avail the membership facilities and additional perks, click the join button. Hello everyone, I Vikas Nehra welcome you all to session number 34 of our ongoing RHCSA version 10 training. And in this session, we will talk about the XFS file system management in Linux. In this session, we will learn a lot of things about XFS file system, like how can we set or change the file system label, how can we mount the file system with special options like noexec, nosuid, noatime, how can we see the file system statistics, what are the commands that we can use for this purpose. After that, we will learn how can we check and repair the XFS file system. In this session, we will not talk about the file system quota management, because in the upcoming sessions, we are going to have a detailed in-depth session on it. Okay, so let's start the session. So this is the machine which I'm going to use, which is running on RHEL 10. And in this machine, I'm going to add a disk here. So I will go in the settings of this machine and I'll click on this add button. I'll select hard disk. I'll select SATA disk, create a new virtual disk option, and store virtual disk as a single file, and click on finish. So I just added a disk in this machine, and I can show you that it will show up here as SDA. The capacity of this disk is 20 GB. So this is the disk which I'm going to use for today's tutorial. On this disk, we will create a partition first, and after that we will format it as XFS. So we will use the fdisk utility to create the partition on this disk. And for new, P4 primary, partition number 1, and this time we want to use the entire disk space. So we'll just press enter here. After that, we will press W to save the changes, and then we can execute the partprog command so that the kernel can read these changes. So I just created a partition on this disk, SDA1. This partition we will format as XFS. All of you are aware that in order to create the file system, or if you want to format a disk or the partition, we can use mkfs command. mkfs.xfs will create the XFS file system on this disk or the partition. After that, we can specify the partition name, obviously. But if you want to set the label while creating the file system, you can use option -capital L. -capital L we can use to set the label, and we can assign or mention the label name. Let us say I want to use the name as my data. So what this command will do, this command will not only format this SDA1 partition as XFS, but it will assign the label to this file system as my data. Look at this. So we have successfully formatted the partition as XFS, and you can see all the details and the attributes about this file system here. Now, how can we see the label? We can execute xfs_admin -l command, and after that we will mention the name of the partition. So the label is showing as my data. Suppose you want to rename it or you want to change the label name. So how can you do that? You have to make sure that the file system should not be in the mounted state. It should be unmounted. So if it is mounted, in your case, you need to unmount it first. After that, you can use XFS underscore admin command -L. After that, you can mention the new label name and then the file system name or the partition name. So this will set or change the new label. And we can verify it by running the XFS underscore admin -l command. Now, what is the purpose of this label? Why do we use it? We can use it in FS tab as well. So if you will run the blkid command for this file system, that is /dev/sda1, it will show you the label name as well. So this name can be used instead of UUID or the device name in the FS tab file. So if you want to use this file system permanently, so you can open the etc FS tab file in VI editor and you can go in the insert mode, and here you can mention the label name like this. In our case, the label name has been changed, which is now as my label. After that, we can mention the mount point name, the file system type. After that, we can specify the options that we want to use, like noexec, nosuid, noatime, and then the file system dump and the check order. So all those details we can mention here. This will help us to keep the file system mounted permanently. But we don't need it, so I'm going to comment this line here. This is just to show you that how can we use the label in FS tab file. Now we will talk about the options which are available with the XFS file system that we can use for different purposes. First, we are going to talk about the noexec option. All of you are aware of noexec. If this feature or option is enabled on the file system, it will not allow the execution of the binary files. So let's create a directory first with the name as testdir on the root directory. And now we can mount this file system with the help of this directory. And here we will specify the option noexec. So how can we do that? We can execute the mount command with option -o. After that, we will write here noexec. Then we will mention the device name or the file system name. And after that, we will mention the mount point name, that is the directory name. So this will mount the file system. This will mount the directory there so that we can access it. And it will also enable the option that have been defined in the command. But how can we verify whether it has successfully enabled the option there or not? So we can look in the etc mtab file. So if we grab SDA1 there, it will show us noexec. That means this option has been enabled. Or there is one more command that you can use, findmnt. Findmnt -o target and options, and after that you will mention the device name or the file system name. So this will also show you the details. So noexec will show up there. Or if you want, you can use the mount command, because mount command also uses this file. Mount pipe grab SDA1. Look at this. noexec is also showing up there. So we can use any of these commands to check and verify whether the option has been enabled or not. Now, as we can see that the file system has been mounted successfully, we can use test.dir directory to keep our data. So let me copy the binary file of the sleep command from the bin directory to our test.dir directory. And now let me show you this file in the test.dir directory. So we have just successfully copied the binary file of the sleep command in the test.dir directory. So if I want to execute this binary file, I have to mention the complete path because I'm not in the test.dir directory there. So I'll mention the complete path, that is the absolute path of this file, and after that I can mention the time in seconds. Suppose I want to run this command for 600 seconds. So I'll write here 600. So it will say permission denied. Why? Because no exec option is enabled on the file system, which will not allow us to execute the binary files. If we will disable this option, it will start working. How? Let me show you. So let me just unmount the file system first. Let's verify it in the output of df-h. And now let's remount it back without no exec option. Okay. Now let's check for the binary file. It is there. And now let's execute this file. So this time the sleep command is executing. The file system is allowing the binary file to execute because this time no exec option was not there. Okay. So let's unmount it back. Let's verify it in the output of df-h. Okay. Similarly, we can use no suid option. No suid will disable the set user ID bit on the file. So let's mount the file system with no suid bit. /dev/stf1/test.dir. Done. Now let's check in the output of cat etc mtab. It will show us this option there, no suid. You can see that the file system is successfully mounted. So we can list the contents of test.dir directory. So this is the file where we are going to set the suid bit. To set the suid bit, we can execute the chmod command, chmod 4555 test.dir sleep. Look, the suid bit is now set on this sleep command binary file. So if I execute this binary file from a normal user account, so it will be executed as the root user has executed it. So it will show us the ID of the root user. But since we have already enabled the no suid bit on this file system, so it should not show the ID of the root user. It should behave normally. That means there is no meaning of having the suid bit here if no suid is enabled on the file system. So let's try to execute this binary file from a normal user account. But before that, I would like to create another duplicate session where I can check it. Okay, so let me switch in the account of Vikas Nehra user, which is a normal user account in my machine. In your case, you can mention the normal user account that you want to use. After that, I'll mention the absolute path of this sleep binary file, and I'll try to execute it. So the command is executing. Now let's check whether we can see the user ID of Vikas Nehra there or not. So we will execute the ps-eo command. So it is showing us the SUID of Vikas Nehra. That means there is no meaning of having the SUID bit on this file. The owner of this sleep binary file is root and SUID bit is set. So ideally it should have shown us 0 in user ID and group ID instead of 1000. But since no SUID option is enabled on the file system, it is executing as a normal file which is not having any SUID bit. Let me show you that this Vikas Nehra user is having the user ID and group ID as 1000. Okay, now let's go back to the root user and let's try to unmount this file system. So the file system is unmounted. Now let's remount it back, but this time we will not specify no SUID option here. Enabled, mounted. Now let's check. This time there is no SUID option is showing up here in the output of the cat/etc/mtab. Now let's switch in the account of Vikas Nehra user and let's execute the sleep command binary file and let's verify it from the other terminal. So this time it is showing us the user ID and group ID as 0. That means the SUID bit is now working on this binary file. Okay. Now let's go back to the root user account and let's unmount the file system. File system is unmounted successfully. Now we will talk about the next option, which is again very important and new. That is mount the file system with noatime option. Noatime option disables writing access time updates to the file system. This is generally used to improve the performance, especially for the workloads involving frequent reads. On several file systems where we want to improve the performance, especially in case of the workloads involving frequent reads, we can enable this feature there. So if we enable this feature, access time will not update on the file system. How? Let me show you. So let me mount the file system with this option, mount -o noatime /dev/sda1/testdir. Now let's verify it whether it is enabled or not. Look at this. No access time feature has been enabled on the file system and file system is mounted successfully. Now let's create a file in testdir directory. This is the file which I just created here from the root user account, and the timestamp is showing the time as 9:48 p.m. Now, if I want to see all the details about this file, like access time and modify time, I can execute the stat command. Stat command will show me all the details about this file, like file permissions, owner of the file, group of the file, SE Linux context of the file, file access time, modify time, change time, and when the file was created. So everything is available. All the stats are available about this file by using the stat command. Here you can see the access time. It is showing up here as 9:48:04, and it is very accurate. You can see how many digits are after decimal. Okay. Now, to create a delay of 20 seconds, let me execute sleep 20 command. Okay. So once the execution of this sleep command is done, after that we will try to access this file. If we access a file, its access time gets updated on the file system. "20 seconds are gone. Now let's open this file. So ideally, access time should got updated. Now let's verify it by running the stat command. Can we see any change here in the access time? No. Let's compare it with the previous one. There is no change in the access time. That means if we want to enable this option, we can mount the file system with noatime option so that the file system access time will not get updated on the file system. Now let's unmount the file system. File system is unmounted, and let's mount it back, but this time we will not define this option there. So we will enable it without noatime option. So we have successfully mounted the file system back, and now let's list the file first. Test_dir new file.txt. Let's execute the stat command for the file. So access time is showing up here as 9:48:04. Same. Let's create a delay of 10 seconds. After that, we will use the cat command to open the file contents. Means we will access the file. Let's access the file by using the cat command, and let's again execute the stat command. This time, look at this. The access time got updated. Earlier it was not. So if we want to enable this feature just to improve the performance of the file system, we can use this option. Okay, now we will talk about how can we see the file system stats. So there is a command XFS_info. Obviously you can read the manual of this command. Display XFS file system geometry information. You can go through the options and the examples. So it will print the entire information about the geometry of the file system. So if you want to see the stats, you can just execute this command xfs_info/dev/sda1. So this will show you the same output that you generally get whenever you format a file system, format a disk or the partition using mkfs command, and at the output of mkfs.xfs, generally you see this information there when you create the XFS file system. So it shows us the metadata, I size, block size. So all those details, if we want to print, we can just execute this command. Because after creating the file system, you only see it when you create the file system. But if you want to see this information again, you can execute xfs_info command. Or if you want to get the in-depth information, or if you want to do the in-depth inspection like metadata logs, so there is a utility xfs_db that you can use. You can read the manual of this one as well. Debug an XFS file system. This command is used to examine an XFS file system. Under rare circumstances, it can also be used to modify the XFS file system. So this command you can use xfs_db /dev/sda1, but you have to make sure that your file system must not be in the mounted state. So you need to unmount the file system first. Okay. So we have just unmounted the file system. Now we can execute this command. So this will give you the prompt like this. And here, if you don't have any information, if you don't know how to use this utility, you can just get the help by writing help here. So there are a lot of options which you can use to get the information like metadata logs and a lot of other details like UUID version. Suppose I want to see the fragment information. So I can write here frag. So it is showing us the fragmentation report. Fragmentation means how many extents each file use. Fragmentation here refers to how many extents, that is continuous chunks of disk, are needed to store the files. Similarly, we can use the other options also. And if we want to quit, we can write here quit. But rarely Linux admins need this utility. So it is of no use. I just wanted to show you. That's why I've shown this command. Okay, now how can you view the file system uses? It's very easy. You can use df-st command, but your file system must be in the mounted state. So mount the file system first. Only then this command will show you the information. File system name, type, size, how much space is in use, how much is available, percentage use, and the mount point name. Okay. Now, how can you check and repair the file system? So if you want to just check the file system for errors and if you want to repair it, make sure that the file system is unmounted. So unmount the file system first. After that, if you want to check using dry run, you can execute xfs_repair command with option -n. So xfs_repair is the command that you can use to check and repair the file system. For dry run, you can write here -n, and after that you can mention the file system name, that is SDA1. And similarly, if you want full repair, you can just execute this command without option -n. So it will automatically check and repair the file system. In the upcoming sessions, we will cover the file system check and repair in detail. So I'm not going to explain those things now in this session. since we have a dedicated session on XFS file system as well as ext file systems repair. So in that session, we will cover these details about the file system check and repair. So that's it from my side for this session. If you have any questions related to today's session or previous sessions, you can ask me now.